Hello once again. I think we can start. My name is Sofia, and our guest today is Sergey Sidorov, software engineer at Meta. The topic for today is how to apply canary releases in practice with lessons from real world deployments. And I think we can start. Sergey, please, the mic is yours.
All right. Yeah. Thanks, Sofia. Thank you very much for having me. Super excited to be here and presenting what is the advancement in the industry for the rollouts, for the canaries, for all of the type of safety measures that we have. So let us get started. Just let me know if you can see the slides. Just message to the chat so I can make sure that we have it.
I think it works, but let's wait some questions. Yes, I think it's working.
So I would like to start slightly far. So essentially, tech industry is evolving rapidly. At the moment, this is not a secret. We have many exciting startups appearing every few months, and those startups solve real-world problems. And what is sort of like the thing that differentiate successful startups? One of them is speed of delivery. So in today's session, we are going to look at how we can enable organizations to move faster and at the same time not to compromise on reliability. It's primarily for software engineers and developers, but it can be also useful for business and product specialists who would like to get an insights on how the core techniques apply to improve the development process and ship things faster and keep things reliable. Before we start, just a quick slide about myself. So my name is Sergey. Yes, I'm software engineer currently working on change safety infrastructure at Meta. You can find more about the work our team does in engineering blog posts. Here, just mention a few examples. One of them is Fox. It is highly distributed queuing infrastructure that powers almost all business products at Meta, including Threads, WhatsApp, Instagram, and others. And this system is a massive scale, operating at like billions of requests per second. And it definitely has reliability challenges, and it definitely requires like safety measures to make sure that a teeny change don't impact users across the globe. Another solution I worked on is Sleek. It's quite popular inside the company. It is a reliability monitoring platform that enables our engineering teams to proactively monitor reliability breaches and eventually utilize the insights, how to evolve reliability further, how to improve, how to adjust their SLOs and reliability tracking metrics. So what is in our agenda today? So we have like a few things to cover. I would like to start with the brief intro into the why it actually matters, why reliability matters, what is the cost of reliability. Then we would like to figure out how it's connected to the rollouts. What do we need to talk about rollouts in the context of reliability? Then we switch to the safe rollout strategies, how the autonomy of safe rollouts looks like, and look at some examples in industry of the architecture of such systems. And I hope we have a good chunk of time for the Q&A, where we can have a live discussion on those topics. So, as I mentioned, speed matters, right? We live in the era of high frequency of software deployments. It's easy to see the data. Mass market software products update several times a day, sometimes delivering hundreds and thousands of changes. Facebook, for example, it pushes like thousands of changes daily to billions of users. The catch is reliability also matters. It's not only about speed, because obviously reliability breaches affect engagement, affect user impression, and the core businesses of the companies, and bugs and issues, they are expensive. And funnily enough, one of the major factor for bugs and for reliability breaches is actually like changes. It actually changes the code. It actually changes the configuration. For example, this is the data for recent study that, I mean, slightly recent from Microsoft, showing the distribution of different service disruptions across their cloud platform. And we can see that the proportion of changes that were bad due to the basically proportion of changes that lead to production issues related to bugs and configs are quite high, sometimes reaching 30 to 50%, varying from workload to workload. And the cost of downtime is actually quite high. So this is like one of the data points from Atlassian research saying, presenting the average cost per minute across industry in general. There are probably other numbers, so it's quite clear that this is indeed an issue. So we have a dilemma now. On the one hand, businesses want to deploy fast, they want to deploy frequent, and adapt to the fast-growing markets. On the other hand, the cost of reliability, breakages, and faulty changes is quite high. And ideally, we would like to optimize both. We'd like to move fast and don't really compromise on reliability. So we're going to walk through the core principles, making changes fast. How do we can utilize this to move faster? And eventually, we'll see why there is no trade-off. It's not a trade-off in practice. To get a better idea of how these principles apply in practice, we're going to use example organization to adopt those principles. So meet New Social. New Social is a social network app for creative people who enjoy sharing a rich content like photos, videos, and they can share their thoughts, connect. It has all of the features you could imagine a social network app, like stories, posts, right? And recently, team launched a new content type, which is live streams, events. And imagine they want to integrate this new live streams into another very popular feature, which is user stories. So we have everything ready to get started on the changes. Development team starting to work, starting to analyze. Let's imagine we are part of the engineering team and we embracing the challenge and starting implementing the feature. Imagine we started to work on New Social recently, and before diving into the work, we decided to recap the current architecture of the system just to see how we can make those changes. So we started with the backend architecture of our app. So we have an app, we have some backend services powering it, and the architecture is very similar. Sorry, it's very simple. It's missing some details, but it will serve as a good example anyway. So our backend consists of multiple services. One of them is feed service, which is used to render initial feed screen containing content from other people, user stories, and other content type. But currently it's missing live events. And the goal of the project is to essentially support this content type during the initial feed. Whenever user open the app, we would like to show them, in addition to the stories that they already see, we would like to show them the live events from other users. So hopefully we don't need to implement everything from scratch. We already have a live events somewhere. We have a live event service, and we need to integrate feed service with the live event service. So this is how the integration could look like. So upon receiving a request to render the initial feed for stories, feed service can fetch different content types we want to show from the storage for stories, and it can also fetch live stream events from the live stream service and return it back to the app. It's as simple as that. Architecture aspect is clear, so we decide to move to the implementation, and we start by looking at the feed service code base just to see how we can integrate this. Our backend is written in C++, and the code for feed service is quite straightforward. Once user tap on the feed on the feed profile, it makes request to feed service, which eventually calls the function getFeed, which takes request as a parameter containing some user details like user ID and some preferences maybe, and return response containing stories. Of course, there are many other things that feed service could do. In real life, for example, it could filter certain stories based on the user preferences like age, continent, like geography, etc. Or it could choose the best content ranking strategy. But for now, we'll focus on the simplest example. So we want to change the function to also return live events as part of the getFeed function response. And this is how we do it. So the change turned out to be very simple. We added a new call to the live event service, which fetches the live events, and then we just add them to the response and return to the users. And we tested the code manually. We tested the code in the staging environment, and everything works perfect. So I think we might be ready to send the change for the code review. We send it, and boom. On the code review, one of the senior engineers raised the concern that deploying the change as this might be not safe, even if it tested manually, because it's pretty hard to find all the edge cases and easy to overlook some of them. They suggested to get the change with a feature flag that can be enabled and disabled automatically. And even if anything goes wrong, we can roll back instantly. So we like the idea, and we decided to use it. So we added a feature flag. Hopefully, our infrastructure supports that. So getting the change with the feature flag turned out to be easy as well. We only modified several lines of code. We added an if statement. We added the check for the enable live events in feed feature flag. But in practice, even though this might look a simple change, it actually means a lot, and we're gaining a lot by using that. So the first thing is we decoupling deployments and release, like two separate things at this point. Future rollouts is now controlled by the engineering teams. They are controlled by developers, not the deploy pipeline. So we don't really care at this point when our code reaches production servers. We care about when we actually enable it to users. And imagine if we have, typically we have many changes going on in parallel. And if we don't have any way to enable changes in a flexible manner, we would need to synchronize across multiple changes. And synchronization is costly, right? So using this approach can allow us to, multiple engineers can deploy features and they own the rollout end to end. And they don't really have a coupling with release, and they don't need to synchronize on that. Obviously, this is good, and it's good. It helps to move faster. The rollout and rollback, as I mentioned, is almost instant because we can simply turn the future flag. And why it matters? So faster recovery typically means we lose less money. Our business loses less money on while we have a downtime, while we have a production issue. Again, this is a benefit. And one of the other benefit, which is quite actually helpful for fast-moving environments, is we can enable quicker prototyping and experimentation using this approach. So we don't really need to have a perfect implementation in place. We can have somewhat decent one, and we can start testing our hypothesis in real life in production using fine-grained rollout principle, like rollout techniques like feature flag, right? For example, feature flags don't necessarily should be binary, like in this example, enable, disable, right? They can accept different parameters, like region, age, and we can use it to A/B test our changes to enable the change for specific users only. So feature flags is a powerful tool, and we decided to follow this approach to use a more granular rollout. So we decided, okay, let's parameterize the rollout by user. So at this point, we can enable feature flag for specific set of users and roll out the feature only to a specific set of users. Typically, companies do it for in different stages. They enable it for internal employees of the company, and then for some percent of the worldwide, so some percent of the external users. And it definitely helps to validate that things works as they should. So after modifying the change, we finally shipped it to production. We enabled the feature flags and successfully rolled out the feature. So we were able to move fast because apparently there were multiple other changes to the app, and eventually we saw that the app became very popular because of those changes, and we were able to ship them fast. So what are the anecdotal lessons from this one? So the cost of coordination is high, right? And by separating deployments from rollouts, we reduce the coordination cost and the overhead that the teams need to maintain in order to ship things in parallel. And feature flags is one of the tools which is quite popular to adopt these techniques. So, but we live in the world where the requirements are evolving, and next day, our new social CTO asked us to make live stories more relevant to users, because apparently they're somewhat relevant, but we see that improvement is possible. So we decide to work on that challenge to make relevance of the live events better. And apparently, we know that we don't really want to change the algorithm of the ranking of these live events. We just want to find the low-hanging fruits and say we want to change the algorithm parameters. And let's say they stored in some configuration file of the live event service. So we applied some changes to the algorithm. We didn't really change the code. We tested it locally, we tested it in staging environment, and indeed we saw an improvement in quality. And one thing to consider, are we confident the change is safe? I think this is the sort of like the cornerstone question, how we can get this confidence. Is it possible to miss anything during the testing? And practice shows it's often possible to miss something. And ideally, we would like to have something similar to feature flag rollouts, as we saw in the previous example. But here we cannot use it because we are applying a change to configuration, and there is no place where we can hack in the feature flag. So, okay, let's say at this stage we don't really know how to do it, how to approach the problem. So we just ship it, and apparently we have an incident. So shortly after config lands, our pager rings, dashboards are red, and user complain about feed tab not working. It's clear that config change caused some issue, and we decided to immediately roll back. After investigation, we figured out that changes to the algorithm parameters have made it a little bit more complex, and we started to see timeouts from the live event service that is returning live events. And because we use it in the feed service, we now started to see some timeouts for feed renderings. But let's say we rolled back the change, and after that, we saw the metrics go well again. We can finally relax. We can finally calm down. But the incidents highlight a deep problem in our rollout strategy. So we cannot prevent bad code changes or config changes in a consistent way. So feature flags can help in case of code changes, but it's not always possible to use them. And it's also very easy to miss. it's practically very hard to empower everyone to use them, and sometimes it's not even applicable. But changes could have a widespread effect on the app reliability, as we saw in this example, right? We landed single change to the config, but apparently it affected everyone, and what is worse, it affected everyone at the same time. So if I can limit the blast radius of the change rollout, it will definitely help us to reduce the impact. We also lose time, and we lose money while performing manual rollback. And especially being in a stressful situation, whenever we need to roll back, on-call engineer spends much more time than we would like it to be. So automated system would handle this much faster, likely. And if you think this is like anecdotal example, I'm convincing you it is not. Few examples from industry. Facebook DNS outage that happened in 2021. It was a simple, maybe not simple, but it was like quite clear misconfiguration in the backbone router system after one of the changes, and it took down the Facebook, Instagram, WhatsApp, and other products globally, worldwide. So the incident lasted for more than 6 hours. Engineers were locked out of internal systems. Internally, it was like, including physical building access, it was very hard to get into the building. So 100% widespread issue. So the problem, we didn't have like staging, right? We didn't have gradual rollout. We didn't have like opportunity to limit the blast radius. Another example that might be quite recent is like CrowdStrike global outage. CrowdStrike is one of the cybersecurity companies that provide some security services for other companies, and apparently they partner with Microsoft to provide services for them. And faulty CrowdStrike update to Windows system where single config caused millions of Windows machines globally to go down. It was like banks, airports, hospitals, governments, airline check-in systems. So everything essentially went into boot loops, requiring some manual repair. So they didn't really have like the way to roll back the change, and the issue lasted for quite a while. The financial implications are huge as well. And the last example is New York Stock Exchange. One of the rollouts in the internal infrastructure introduced a configuration error, and unfortunately, it halted the trading systems, and all symbols on the stock exchange were unavailable for about 3 hours, and investors, traders, they weren't able to buy or sell for this time period, which was like resulting in trillions of market value loss. So configuration changes are quite dangerous, and we should have a way to prevent them. So let's summarize what we know so far, right? We know that bad changes quite expensive. They cost companies quite a bit in terms of they cost operational cost, right? People have to, on-call engineers, software engineers, they have to work on the reliability follow-ups. They have to work on troubleshooting, debugging, investigations. And according to one of the research by Stripe, it's actually quite a big number. It's 4 hours per week per developer spent on this routine, which is equivalent to slightly more than 80 billion dollars annually, which is a huge number. And it doesn't include some direct financial losses due to the reliability breaches for those businesses, like revenue, like ads, engagement, etc. Feature flags and testing, like manual testing, staging testing, aren't enough on its own. So safe rollouts should be there. They should control exposure. They should measure metrics in real time, and they should provide a way to roll back automatically whenever there is a deviation in the metric. And another thing is everything is a change. So essentially, ideally, we would like to have a similar safety guardians for any type of change that exists in the company, including code changes, configuration changes, and other changes like ACLs, for example. And it ultimately it requires us to have some last line of defense. So even if I get to add a, let's say, future flag, let's say if I get to test it properly or miss some edge cases, there should be like a last line of defense to limit the blast radius and to ensure that if something goes wrong, the impact is sort of like isolated and limited. And here is essentially where progressive rollouts comes handy. So in a nutshell, progressive rollouts is used to catch bugs early. As I mentioned, they allow us to continuously measure the rollout quality, and in case of issues rollback, they have these monitoring systems. And ultimately, because we don't roll out all at once, we can limit the blast radius, affecting only a small percent of users. And we can also have some safe rollback mechanisms whenever issue happens. And last but not least, it can be used to validate the business impact. It can be used as part of the A/B testing pipeline whenever we roll out some product changes, some product features changes. We're actually able to see how the engagement, for example, is changing for by this change. So, in a nutshell, progressive rollouts, they have many different types and forms, but for the sake of the presentation, we'll focus on the core aspect of those. So essentially, instead of rolling out everything at once, we would like to have a more fine-grained approach to push it in stages. Let's say we have multiple stages. Let's say we have a service version 1, like in this slide, and we would like to roll out a new version of the service. So we can start simple, right? We can roll out the single machine first, right, and monitor the metrics, see if everything is all right, or if something is not. If everything is all right, we can continue to the next phase. The velocity, how many machines we select at each step, is controlled, and it always it is always taking into account such factors as like risk tolerance and criticality of the particular deployment pipeline. But in general, the core idea is like, okay, let's not deploy to everything. Let's deploy gradually, machine by machine. This sounds like a very simple idea, and this is integrated with some mechanism to evaluate the health of the pipelines. So let's say if we have an issue and we have to roll back, this is quite easy, right? We basically identify that there is like a node that is failing, and we are ready to roll back. Because everything is a change, we don't really care if it was a code change or config change. The same thing applies. We can have the same version, the code version of the service, but we change the config. Same thing. It's basically rolling out to a particular node first, right? And if we consider that this node behavior that is using a new config is different, in a bad way different, I mean, like we have a degradation in the metrics, then we can automatically roll back. So this is adopted technique by some industry players, and I just want to give a few examples. So one of them is Conveyor. It's internal Meta platform for continuous deployment and continuous delivery, and it's well integrated with the rest of the Meta infrastructure. For someone who's interested in how the architecture for the system looks like. So the first thing is Conveyor is integrated with the every aspect of like infrastructure. And this allows like for a very good flexibility in terms of how do we manage deployments pipelines. On this diagram, you can see that we have like deployment pipeline to build code, to create an image, and to deploy it. And all of this is managed by Conveyor. Conveyor is also integrated with the configuration management system. It also integrated with the health check service, some similar component to what we already saw on the diagram before. It integrated with the cluster management software. So essentially, if we want to deploy something and would like to use a staged rollout and we want to use like progressive rollouts, the way how it typically works is we select some representative tasks that is running particular service. We roll out this task to this. We roll out the new version of the code or config to those nodes. We able to switch traffic between them because we have a unified service mesh which is integrated with the Conveyor as well, and it can redirect traffic depending on the rollout stages of this particular machine. And we can typically use those different groups of services, the ones that we don't really have the new version deployed to, and the ones that where we have a new version, and we can compare some metrics. It's going to be system level metrics like CPU utilization, traffic rate, etc., as well as business level metrics, how it's driving the revenue, how it's driving the engagement, etc., etc. And using these signals, we can make informed decision whether to continue with the rollout or rollback. So Conveyor is well adopted. It has like 100,000 deployments per week, and around slightly more than 2% of rollouts and like phase transitions that we illustrated before stopped by health checks, meaning that those 2% could actually result in an issue if we didn't have this integration and didn't have this issue, which is obviously would impact billions of people worldwide, affecting having like a impact on the company reputation, on the businesses, etc. It is not only available for corporations. It doesn't mean that if it does not matter, or like in some different corporation we cannot benefit from using such techniques like Conveyor and such tools. For example, AWS, very popular cloud provider, provides somewhat similar tooling for canaries, for deployments. Code deploy. Here's the link. You can check it. It's very similar in terms of how it works to the what we described before. For Google, it is also implemented as part of the Google Cloud Deploy, which supports like a feature-rich configuration for deployments, including health checks, including staged rollouts and canary. And one of the tools used by other companies like Netflix is basically Spinnaker, which is basically like a superset of the features above that supports everything that we discussed today. So I think we should be ready for Q&A.
So thank you for the webinar. It was a little bit technical, but very interesting and informative. So we're moving into the Q&A session. Please, if you have any questions, drop them in the chat box, please. There are several questions, and we can start. The first question from Nina. Can small teams benefit from canary releases, or it's more suitable for large organizations?
Yeah, that's a very good question. So actually, I would rephrase it. They should benefit from canary releases the same way as big organizations benefit, because the cost of changes hitting production is quite high for both, relating to revenue for both small organizations and large organizations. What is good? There are plenty of tools that I I just demonstrate a few of them, but there are plenty of tools available outside in open source that can be used to build similar environments and similar pipelines. So the answer is definitely.
Okay, thank you for your answer. The next question is from Ethan. How automated should be rollbacks? Isn't that risky?
Yeah, this is a good question. So essentially, there's always a risk. The thing is, what is more risky, manual rollback or automated one? Often manual rollback is more risky because it's performed under pressure, because there is a production issue and human intervention is required. There is a chance to make a mistake. And in fact, there are plenty of issues when mistakes are made at the stage of fixing other issue, trying to roll back something. So I would say the answer would be there is a risk. It is always there. We should accept it, but it's definitely less risky than automated. I mean, it's definitely less risky than manual, and it's definitely beneficial in terms of saving us the recovery time, because automation can act faster and roll back faster whenever issue happens, while humans, we unfortunately need to some time to analyze and understand the problem, and every minute of downtime costs us money.
Thank you. I think the next question is very interesting as well. What if we don't have the infrastructure for full canary pipelines like Meta?
Yeah, I think this is one of the. I mean, this is similar question that I think to what Nina asked. So I think you don't need to have similar infrastructure. Many small to medium-sized businesses, even large businesses, they deploy to cloud providers. Like let's take Netflix, for example. They deploy to AWS. This is not a secret. And fortunately, you can benefit from those techniques and pipelines using these cloud providers. Yeah, I think we can share the links to these tools as part of the presentation.
Thank you. The next question from Marco. What's the most common failure mode you have seen during rollouts?
Yes, that was interesting. I didn't think about that. I think the most common, it's hard to say, but I think one of the frequent failure pattern is assumption that if it's a small change, I can just deploy it and everything will be all right. I think this is pretty dangerous assumption, as we saw. Some of the incidents I demonstrated, they were actually small incidents, especially those with the config changes, small relative to the whole system, to the business, right? Unfortunately, it's rare when small changes like that appear like not risky at the first glance, result in a severe degradations. So I would say this is one of them, right? And we definitely should have some safeguards to prevent these changes from increasing production.
I think one more question from Nina, and very relatively for me. And how do you explain canary release to someone without a tech background?
Yes, this is a good question. So essentially, we have to move fast, right? We have to make changes to our products if we want to stay competitive on the markets. I'm talking about tech products, like applications, like and this type of things. And essentially, whenever we make a change, there's a risk always, right? And we saw that the cost of if the risk is actually comes true is quite high. Canary is one of the technique that can be embedded into the release infrastructure, into the release pipeline, into basically being as a gate before your changes hitting the users. You have some sort of like some layer, right? Some layer of protection that prevents this change from hitting the users, and it prevents it in some intelligent way, I would say, by limiting the number of people being affected by the service and doing it step by step, essentially. So whenever, like, let's say simple example is you roll out to the few percent of users, then you roll out to 5%, 10%, and at every stage you have a signal, clear signal, whether your rollout is safer or is safe or not. And this is ultimately the high level goal of this approach. And you don't really need to have you don't need to have feature flags, or like you don't need to rely on that. This is like another very important aspect here, because someone can miss it. Some products can go live without that, but you still have to have this like last layer and defense and protection to prevent these changes from hitting users.
Thank you. The next question is, how do you decide what metrics to monitor during a canary?
Yes. So typically, there are different types of metrics that we can monitor. So it starts with the system level metrics. So for our service, for example, that we demonstrated in this presentation, we can measure some like utilization of the resources. We can measure the at which rate users actually requesting the feed. So do we have like some degradations? We can measure how fast we can respond, like latency to those queries. And typically, it's usually like 5 metrics like that that provide a good signal in terms of like, okay, is it more or less healthy or not? The next layer of metrics is business level metrics, or like domain level metrics. This is the place where we basically want to see, okay, we made a change and it's more or less safe. I mean, it's continuing functioning, the feature continuing functioning, but we'd like to understand, does it actually solve the job? Does it actually solve the problem that we're trying to solve? Like, for example, in that case that we demonstrated in this presentation, we wanted to increase engagement, right, from integrating the different features together. So this is one of the ways to see, okay, is engagement going down or not as part of the rollout? And if it's going down, we can roll back. And this is pretty much as simple as that.
Thank
So
you.
you have to have, so just to finish on that, sorry, like you have to have, it's specific. There's like system specific metrics. They're sort of like more common, and you don't really need to have like, they're basically more or less same. But domain level definitely requires understanding of the business.
Okay, thank you. One more question. How do canary releases differ from just using feature flags?
Yes. So this is, in a way, we don't really contrast them. We don't really, they're not mutually exclusive. Essentially, they can be used and should be used together for better safety and better protection, because feature flags is one of the ways to have a gradual rollout, have a progressive rollout, and to have more fine-grained control over how your changes being seen by users. But on the other hand, there is no guarantee that it's always possible to use. There is no guarantee that someone will use it. Some developers may use it. So another day you might actually forget about that, or like, miss it. Canary or progressive rollout strategy is the way to establish safeguards, the very last layer of protection. That is, even if you miss the feature flag, you should still be able to catch the issue. At this point in time, yes, of course, you might impact users, but your blast radius and the impact will be much lower than without that. So this is essentially the difference that I would like to highlight.
Thank you. Thank you very much. And looks like we have covered everything for now.
Right.
Thank you to Sergey for leading such a useful webinar for us. If you'd like to keep the discussion going, you can connect with Sergey on LinkedIn and subscribe to the Top Voices newsletter and follow us on LinkedIn to stay updated on upcoming events and expert talks. All links can be found in the description below. And thank you once again. And we hope to see you in the next session.
Thank you, everyone. Thanks, Sophie.
Thank you.